Let us quickly recall what we saw in the previous video and then do some examples using the ideas that we have seen in the previous video. First of all, we discussed previously what is a quadrilateral and what is a parallelogram. Quadrilateral is a four-sided figure. It has four sides, four angles, and four vertices. And a parallelogram is a special kind of a quadrilateral in which both pairs of opposite sides are parallel. We have talked about this in the previous video. And then we have seen some properties of the parallelogram. So let's recall quickly what are those properties, and then we will use those properties to solve some examples. The first property of the parallelogram that we saw earlier is that the diagonal of the parallelogram divides it into two congruent triangles. So when you make a diagonal, the diagonal is dividing it into two congruent triangles. The next property we saw is that the opposite sides of a parallelogram are equal, and again we will use this idea in solving some of the problems that we will see today. And of course this property has a converse statement which states that if the opposite sides of a quadrilateral are equal, then it is a parallelogram. So a parallelogram has opposite sides equal. Conversely, if a quadrilateral has opposite sides equal, then that quadrilateral is a parallelogram. The next property is that the opposite angles are equal for a parallelogram. So angle A is equal to angle C and angle B is equal to angle D. So opposite angles are equal for a parallelogram. And conversely, if the quadrilateral has opposite angles equal, then it is a parallelogram. Again, these are stated, this property is stated in its general form and in its converse form, and is stated as theorems, right? And then we have the next property which states that the diagonals of a parallelogram bisect each other. That means the diagonals intersect in such a way that the intersection divides the diagonals into two equal parts. So OA is equal to OC and OB is equal to OD. So the diagonals of a parallelogram bisect each other, and conversely we can state that if the diagonals of a quadrilateral bisect each other, then that quadrilateral becomes a parallelogram. Okay, so we have seen all these properties in the previous video. Now we will apply some of these properties to solve some examples. Let's take the first example. And before that, we also saw some common parallelograms that we are all familiar with, like we talked about a rectangle, a square, and a rhombus. Okay, we have seen what are all this. We are familiar with this. So let's quickly go to the example and solve it. The first example states the question is that we have to show that each angle of a rectangle is a right angle. So we have a rectangle here, and we have to show that all the four angles in the rectangle are right angles. So we want to show that one of the or all the angles in the rectangle are 90 degrees in this example. So since this is a rectangle, we know that one of the angle is 90 degrees. So let me denote this rectangle as ABCD, in which angle A is 90 degrees. So this angle A here, let me mark that. Angle A is 90 degrees. Okay, so ABCD is a rectangle. Okay, and in this rectangle we say let angle A equals 90 degrees, and we have to show that angles B, C, and D are also 90 degrees. So let me write what we have to show. We need to show that angle B equals angle C equals angle D, and all of them equals 90 degrees. So when one of the angle is a rectangle, then all the angles are also one of the angles is a right angle, then all the angles, the rest of the angles are also right angles. Okay, how can we show that? To show that, if you consider this right angle over here, consider the lines AD and BC. Okay, these are parallel lines because this is a parallelogram in which one of the angle is 90 degrees. A rectangle is a parallelogram in which one angle is a right angle. So side AD and BC are parallel to each other. So we say that AD is parallel to BC, AD parallel to BC. In that case, what happens is, if AD is parallel to BC, it looks something like this. So let's say we have this as AD and this as BC. Then we have AB is like a transversal to these parallel lines, right? And there is a rule that in the transversal, when you have two parallel lines cut by a transversal, the sum of the interior angles on the same side of the transversal is 90 degrees. That means this angle plus this angle equals 90 degree, equals 180 degrees. So here if you see, we have the side AD and BC parallel to each other. AB is the transversal cutting through those parallel lines. So the sum of the internal angles, which is angle A plus angle B, will be 180 degrees. So for parallel lines cut by a transversal, for parallel lines cut by a transversal, sum of interior angles on the same side of transversal is 180 degrees. This we have seen in the parallel lines chapter. So that means angle A plus angle B should be 180 degrees. So therefore angle A plus angle B equals 180 degrees. We know that angle A is already 90 degrees. So angle B will be, so angle A is 90 degrees plus angle B equals 180 degrees. So therefore angle B will be equal to 180 degrees minus 90 degrees, which is equal to 90 degrees. So we have got that angle B is also 90 degrees. Once we have proved that angle B is 90 degrees, then we can find angle C and D directly from the property of the parallelogram, that in the parallelogram the opposite angles are equal. So we can say that angle C is the same as angle A. Angle C equals angle A, and angle D equals angle B, and these are all equal to 90 degrees. So that's also equal to 90 degrees. That's also equal to 90 degrees. Why? Opposite angles in a parallelogram are equal. So this comes from the property that opposite angles in a parallelogram are equal. Okay, so hence we have proved now that angle C is equal to 90 degrees, angle D is also 90 degrees. Therefore, each of the angles of this rectangle are 90 degrees. So all the angles in a rectangle are 90 degrees. And we start with the definition that a rectangle is a parallelogram in which one of the angles is 90 degrees. And then we go on to prove that the remaining three angles are also 90 degrees. Let us now do the second example. So in the next example, we are given a rhombus and we have to show that the diagonals of the rhombus are perpendicular to each other. Remember that the rhombus is a parallelogram in which all the four sides are equal, but the angles are not equal to 90 degrees. Okay, unlike a square in which all the four sides are equal and the angles are 90 degrees, a rhombus, the sides are equal, all the four sides are equal, but the angles are not equal to 90 degrees. So we have a rhombus here, ABCD. So we consider this rhombus ABCD, and we have to show that the diagonals, okay, AC and the diagonals AC and BD are perpendicular to each other. That means the angle between AAC and BD is 90 degrees. That's what we need to show. So let us consider this rhombus ABCD, and since it's a rhombus, all the four sides are equal. So we have all the four sides, AB equals BC equals CD equals DA, because it's a rhombus, a rhombus is a parallelogram in which all four sides are equal. Okay, now to prove that the diagonals are perpendicular to each other, we will consider the two triangles, the triangle AOD and triangle COD, okay, and check for their congruence and prove if they are congruent or not. Once we prove their congruence, then we can apply the CPCT rule, the corresponding parts of a congruent triangle rule, to find the angles. Okay, O is the meeting point or intersection point of the two diagonals AC and BD. So consider first the two triangles AOD, so this triangle over here, and the triangle COD, this triangle. So let's write down. So in these two triangles AOD and COD, the first thing we note is that the sides OA and OC are of the same length. So side OA is equal to OC. Why is that? Because the diagonals of a parallelogram bisect each other. So the intersecting point divides the diagonal into two equal parts. So therefore OA equals OC. Why? Because the diagonals of a parallelogram bisect each other, and a rhombus is a parallelogram. The next thing we see is that both these triangles, triangle AOD and triangle COD, have the side OD as a common side. So we can take that OD equal to OD because that side OD is common to both these triangles. And finally, the side AD and the side CD is also equal because all the four sides of the rhombus are equal in length. So we say AD equals CD. This is already known. AD equals CD. So sides, because they are sides of the rhombus. Sides of rhombus. Okay. So now we have, excuse me, now we have all the three sides are equal. So we can say by SSS congruence, the two triangles AOD and COD are congruent. Triangle AOD is congruent to triangle COD. So once we have the two triangles to be congruent, we can now show what the angle AOD and COD will be. Okay, so we can talk about this angle here, this angle, and this angle. These angles will also be equal by CPCT, by corresponding parts of the congruent triangle. The corresponding angles must also be equal. So we say now by CPCT, angle AOD is equal to angle COD. So these two angles are equal by the rule of CPCT. But we also see that the diagonal AC is a straight line on which a ray OD is standing. So that angles AOD and COD are linear pair of angles, right? So in a linear pair of angles, the sum of the two angles is 180 degrees. So also, we say that also angle AOD plus angle COD should be equal to 180 degrees. Why is that? Because they are a linear pair of angles. Now we already know that angle AOD and COD are equal to each other and the sum of them is 180 degrees. So if AOD and COD have the same values and the sum is 90 degrees, then each of them must be 90 degrees. So 90 plus 90 will be 180. So AOD and COD are equal. That's the first thing we know by CPCT. And we also know by the linear pair rule that AOD plus COD is 180 degrees. So if we add two values of two angles which have the same value and the sum has to be 90 degrees, then that means each of the angles must be, and the sum has to be 180 degrees. That means each of the angles must be half of 180 degrees, which is 90 degrees. So since AOD and COD are same, we can write this as angle AOD plus AOD, angle AOD plus angle AOD, because COD is the same as AOD, equals 180 degrees. That means 2 times angle AOD equals 180 degrees. So therefore angle AOD is equal to 180 degrees divided by 2, which is 90 degrees. So this angle AOD over here, AOD, this angle is 90 degrees. That means this angle here is 90 degrees. So that means the diagonal AC and the diagonal BD have an angle of 90 degrees between them. That means the diagonals are perpendicular to each other. So we can state that the diagonals are perpendicular to each other. So hence we have shown that the diagonals in a rhombus are perpendicular to each other. Okay, so we started by taking the fact that all the 4 sides in a rhombus are of equal length, and then we took the 2 triangles AOD and COD and proved their congruence and showed that they are congruent according to the SSS congruence rule, and then we applied the CPCT rule to find a relationship for the angles AOD and COD, and we showed that they are equal as per CPCT. And then we applied the linear pair rule to show that the sum of these 2 angles is 180 degrees, and from that we obtained that the angle AOD is 90 degrees. That means the angle between the 2 diagonals is 90 degrees. In other words, the diagonals are perpendicular to each other. Let us now do one more example based on this parallelogram concept, and we will stop after that for this particular lecture. Okay, let us do this example here. In this example, we are given a triangle ABC, okay, and it's stated that ABC is an isosceles triangle. That means 2 of the sides are equal. So the side AB is equal to the side AC. AB and AC are equal. This is given to us. And then we are shown some extension of this triangle. Okay, the side AB of the triangle is extended upward further to the point P, and there is another line AD which is bisecting this angle PAC. Okay, so there is an angle PAC, which is this whole angle here formed on this extension. Okay, the extension of AB, the angle formed between the extension of AB, that is AP, and the side AC, that angle is PAC. So that angle PAC. Now there is a line AD drawn from the point A such that it bisects the exterior angle PAC. That means this line AD is dividing this angle PAC into 2 equal parts. So it is dividing it into 2 equal parts like this. So that's one equal part and that's another equal part. So line AD is dividing it into dividing the angle PAC into 2 equal parts, bisecting the exterior angle PAC. And we are also given that the side AD, the side AB and CD are parallel to each other. So these two lines are parallel to each other, and we are asked to prove two things. The first thing is we are asked to prove that the angle DAC, which is this angle over here, DAC, and the angle BCA, that is this angle over here, they are equal. So we need to prove that. And then we also have to show that ABCD is a parallelogram. To show that ABCD is a parallelogram, we have to prove that the line AD and BC are parallel. We are already given that AB and CD are parallel to each other. So we have to show that AD and BC are also parallel in order to show that this ABCD is a parallelogram. Okay, to do this, the first thing we have to do is we need to look at the triangle ABC. We are given that AB and AC are equal, and we know from the rules of the isosceles triangle that the angles opposite to the equal sides are also equal. That means angle ABC is equal to angle ACB or angle BCA. Okay, we can write it ACB or BCA. So these two angles are equal. So let's first solve the first part of the question. Okay, solution. Okay, let's solve the first part. Now, since the sides AB and AC are equal, opposite angles are also equal. So therefore angle ABC is equal to angle ACB. Opposite angles of equal sides. Okay, these are angles opposite to equal sides. Angles opposite to equal sides. So therefore these two angles are equal. Which are those two angles? It is this angle ABC and ACB. They are equal to each other. So that's the first thing we show here. And then we use a property of a triangle that the exterior angle of the triangle is equal to the sum of the interior angles on the opposite side. Okay, what this property means is that the exterior angle of the triangle, which is, say, I'm making this triangle separately here in the bottom diagram, this angle here is equal to the sum of these two angles. Okay, so the exterior angle, so if I call this triangle A, B, C, and I can mark this point as P, then the angle PAC here, angle PAC is equal to angle ABC plus angle ACB. This is called the exterior angle of a triangle rule. So similarly here in our problem here, we have this angle PAC that is equal to angle ABC plus ACB. Okay, so these two angles, the sum of these two will be equal to the angle PAC. So let's write that down. Angle PAC is equal to angle ABC plus angle ACB. And since angles ABC and ACB are equal, we can write this as equal to 2 times angle ACB. Okay, or let me write that one extra step here. So ABC is the same as ACB, so ACB plus angle ACB, which is 2 times angle ACB. So we have here angle PAC, which is this exterior angle PAC, is equal to 2 times ACB. The next thing is, we also know that the angle PAC is bisected by the line AD. So the angle DAC is half of angle PAC, right? Or PAC is 2 times DAC. So now, since the line AD is bisecting the angle PAC, so the angle PAC is equal to 2 times the angle DAC. So DAC is this angle over here. So the total angle PAC will be equal to 2 times the angle DAC. So 2 times DAC. Now we have these two equations. The first equation is over here. If I can call this as first equation and this one as the second equation. So from the first equation we are getting that angle PAC is 2 times ACB, and from the second equation we are getting that angle PAC is 2 times DAC also. So that means 2 times ACB and 2 times DAC are equal because they are equal to PAC. So we will get, so therefore from 1 and 2, from equation 1 and let me write that clearly, and equation 2, we get that 2 times angle ACB equals 2 times angle DAC. So therefore it means that angle ACB equals angle DAC. So what we see here is that this angle here, DAC and ACB, they are equal. So I will mark that also with the red. So this angle here and this angle over here. Okay, so these two angles are equal. Now what we see is that these two angles also form alternate angles, right? So if we consider AD and BC as parallel lines cut by this transversal AC, then this angle DAC and angle ACB are alternate angles, and alternate angles are equal only when the lines BC and AD are parallel to each other, cut by this transversal AC. So when two lines are cut by a transversal and if the alternate angles are equal, it means that those two lines are parallel to each other. So since the two angles ACB and DAC are equal, it means that they are alternate angles of the parallel lines BC and AD cut by the transversal AC. So let me write that on the next page. Now since these two angles are equal, ACB and DAC, it means they are alternate angles for two lines AD and BC cut by the transversal AC. So using this we can go on to show that ABCD is a parallelogram, because we already know from the question that AB and CD are parallel. We only need to show that BC and AD are also parallel, which we can prove by the alternate angles rule. So let's go ahead and do that. So we already have from our first part of the solution, angle ACB, which is this angle, is equal to angle DAC, and these are alternate angles. So let's write that. So we have this angle ACB and angle DAC are a pair of alternate angles when the line segments AD and BC are cut by this transversal or intersected by this transversal AC. So when the alternate angles are equal, it means that the line segments AD and BC are parallel to each other. So since the alternate pair of angles, angle ACB and angle DAC are equal, it means that the line AD is parallel to the line segment BC. So AD is parallel to BC, and we are also given that AB is parallel to CD. This is given in the question, and therefore we have the two opposite sides of this quadrilateral parallel to each other. So therefore we can say that ABCD is a parallelogram. So we have proven the second part of the question, that ABCD is a parallelogram. Okay, we'll stop here with this example and we'll continue with some more examples in the